All right. Good afternoon to all our attendees who are tuned in to celebrate the National Science and Technology Week with us. Allow me to introduce myself. My name is Therese Gilnat, and I will be your host for today. So we are now on our last webinar for this week. But before that, let me take this moment to express our gratitude for your support, especially to those who have been attending our previous webinars for the past few days. So for today, we are going to talk about the applicability of machine learning in weather forecasting as a supplement or an alternative to the traditional methods. But before we proceed, may we please invite everyone for the singing of the Philippine National Anthem. Again, thank you for spending your afternoon with us. Just a few reminders before we start the program. Please be informed that this online event is being recorded. Participants may type in their questions in the chat pane to be addressed by the speakers and moderators during the panel Q&A session. So for those who are streaming through the DOST-ASTI Facebook live stream, you may send us your questions by typing them in the comment box. We will also be having a quick photo opportunity towards the end of the webinar, so stay tuned for that. To our friends from the media, you may access the official event press kit by visiting the URL flashed on the screen. Can we have the press kit URL? Thank you. If you would like to schedule an interview with our speaker, you may reach out to us via email at media@asti.dost.gov.ph. So for everyone's reference, this is our program for today. I hope you can stay with us until the end of this webinar, because as you can see, we have a lot of interesting topics lined up for you this afternoon. So without further ado, here is our DOST-ASTI Director, Dr. Franz De Leon, to deliver the welcome message.
A pleasant day to everyone who are present for today's event. Thank you for celebrating this year's National Science and Technology Week with us. We're very excited to show you new developments on a few of the DOST-ASTI's projects and programs for this year. It is with great honor that I welcome you all as we share with you new technologies and advancements developed by our talented team of researchers with the goal of benefiting our society. Over the past year, we have been committed and continuously working to deliver relevant and timely technological innovations that provide ease in everyday life of our fellow Filipinos. The current situation caused by the pandemic has further challenged our institute to produce technology-driven solutions that will help make services for our country more accessible to people and for the government to provide accurate data and information to the public. Right now, we have been providing these services to various parts of the country in planning for disaster response, agricultural solutions, and satellite imagery, to name a few. In this event, we will be discussing the ULAT project, or Understanding Lightning and Thunderstorms project, which observes the country's weather behaviors through studying torrential rainfall and thunderstorm occurrences as parameters to eventually enable short-term forecasts. Thanks to our very own developers and researchers from the DOST-ASTI, We aim to share with you all how this innovation works and how it is relevant to the progress of society. We are looking forward for everyone to grow more interest and appreciation towards science and technology as we start today's webinar. Thank you and have a good day.
Thank you, Director De Leon, for your usual support. Now we proceed to the main part of our webinar. Again, if you have any questions or comments to our speaker, just type them in the Q&A box here in Zoom or in the comment section of our Facebook live stream. Okay, so we are happy to have Mr. Elmer Peramo as our speaker for today. He is currently a senior science research specialist at DOST-ASTI. He holds a bachelor's degree in computer science at Mondrian Ora College and a master's degree in electrical engineering at UP Diliman. He's also a PhD student in computer science at the De La Salle University. So his research focus is on artificial intelligence and its applications in various fields. He's also a technical researcher of the Understanding Lightning and Thunderstorms or ULAT project, which he will be talking about in just a while. So Sir Elmer, the floor is yours.
Thank you, Nicole. Good afternoon, everyone. Thank you for tuning in. I'm Elmer Peramo, a Senior Science Research Specialist in the DOST-ASTI. And my area of research is like what, Therese, I'm sorry. Thank you, Therese.
True, sir.
And yeah, sorry about that. And yeah, you were saying that my area of research is in artificial intelligence. And for today's webinar, allow me to share with you how AI or machine learning can be used in weather forecasting. So should we wear a jacket or a sandal today? Should we go to the office or work from home? These are some of the everyday questions that might be able to answer with the help of a weather forecast. I'm sure we're all familiar with weather forecaster that we see on TV, within the news program that we watch. See, there are different types of weather forecasting depending on the time horizon that it can be long term for the things. If you're going to forecast the weather for 2 weeks or more or from now, and medium term, if forecasting what the weather will be in the next coming days. Longer than that, I think that usually falls in the area of climate prediction or climate modeling. So I think the majority of us will be interested in short-term forecasting, so which extend up to 40 hours. Now, there's a new kid on the block, nowcasting. So weather nowcasting is a very short-term forecasting that ranges between 1 and 6 hours. So these are not hard thresholds, but basically, you know, the idea behind the temporal resolution of the weather forecasting, and I'm sure common sense will dictate that predictability will is dependent on the temporal resolution. I think it would be harder for us to really determine the weather if we're going to predict the weather probably longer than the short-term time horizon. But remember that these forecasts have also spatial limits. So the weather in one place or one locale can be very different in another geographical area. So temporal and spatial resolution play a different, I mean, it's really different if you're going to predict the temporal and the spatial parameters of your prediction is really a consideration for meteorologists. Now, I mentioned meteorologists. You see, meteorology is the science of weather, climate, and other atmospheric phenomena. So weather forecasting is a big part of this science, and accurate time and timely weather has always been the goal of meteorological scientists. So why do we need accurate and timely weather forecasts? I guess we all know the answer to that. I just want to highlight them so that we won't take them for granted. You see, various human activities have always been sensitive to prevailing weather conditions. So people have been trying to predict the weather since the ancient times. When we're faced with dangerous weather conditions like thunderstorms, our decisions between what should and shouldn't do, I think, can often mean the difference between life and death. So weather forecasting plays a very crucial role. And early warning of weather impacts various aspects of human livelihood. It affects our transportation based on air, on land, or in sea. For instance, weather forecasting provides decision-making support to reduce traffic accidents and traffic congestions, which completely depend on the sensing and predicting of external environmental factors such as rainfall or air visibility and so on. You see, utility companies and private businesses are also affected by the weather. So would they stock more of what products? I think the future weather conditions will have something to say about that question. Not only the businesses are affected, but also our agriculture, fisheries, and even the military. In our country alone, we are definitely affected by the weather. Located along the typhoon belt in the Pacific, the Philippines is visited by 20, an average of 20 typhoons, or about 5 of which are very destructive and causing lives and properties amounting to billions of pesos. So now that we have established the significance of weather forecasting, you may now probably ask, how do the scientists come up with their predictions? So one of the more common and traditional methods of weather forecasting is the numerical weather prediction. Okay, NWP uses mathematical and physical models of the atmosphere and the oceans to predict the weather based on the current weather conditions. So this is a computerized model given an initial state derived from basing on the data that you have, observations, humidity, wind speed, temperature, atmospheric pressure, etc. You have to generate forecasts on how the weather will evolve into the future. So these models are usually expressed in differential equations and simulations, and they are solved using high performance computers. So, but are there other ways of doing this? Now, the recent hype about artificial intelligence has sparked renewed interest in applying the success of deep learning methods to image recognition, speech recognition, natural language processing, or robotics, strategic games, and now even to the field of meteorology. So a couple of months ago, DeepMind, an AI company owned by Google, has developed a new machine learning model that can accurately forecast whether or not it will rain into the following future. So this is called precipitation nowcasting. So basically what they did, they have radar images of the atmosphere, and then they use what is called a generative adversarial network. It's a deep learning model to predict what would be the next outcome or the next possible scenarios. Okay, so that's actually how they were able to get a very accurate prediction, and it's been validated by 50 UK meteorologists. Now, before I delve in further, let's define terms I mentioned here: AI, deep learning, and machine learning. So AI is the development of system that mimics or simulates human intelligence, perception, language, understanding, cognition, reasoning, and all. So basically, it's a development of how does the human actually human intelligence is being mimicked by machines. No, so but you see that AI, most of the AI that we've been hearing nowadays, okay, much of the technology is actually machine learning. Okay, machine learning is that area of AI that allows decision makers to gain more insight from data. So this is more data-driven. This is a data-driven part of AI. So the application of machine learning is varied, and this includes weather forecasting. And actually, there's a growing trend in the sciences wherein, like for example, in the area of physics, in the area of chemistry, they are now going, before we know them to be experimental or empirical, but the next paradigm would be the data-driven paradigm. They are now jumping into the bandwagon of using AI and machine learning in their fields, in physics, in chemistry, now in the area of meteorology. Okay, so there's a valuable opportunity to use machine learning to obtain more concise and in-depth information from available data, including weather data. There are two types of machine learning. One is supervised and the other one is unsupervised learning. The primary goal of supervised learning is to learn how to predict group or a value from past data. So by another definition, supervised learning is a machine learning task of inferring function from a labeled training data. The keyword here is labeled. Okay. Now, unsupervised learning tries to identify patterns in data sets containing data points that are unlabeled. So it does this inherently, and basically you're just trying to detect patterns inherent in the distribution of the data, and clustering is an example of unsupervised learning. It can also be used to analyze your data set or before doing a supervised learning approach. So majority of machine learning uses supervised learning. So here's how it works. So you have labeled observations from, for example, in our case, we collect a lot of data from sensors, from satellite images, from radar images, for example, and then data from those sources, okay, are collected, or they are cleaned, and then they are split into training and test sets. And basically, they are transformed to a more structured form so that they can be fed into a machine learning algorithm. And then the output of that algorithm is a predictive model that can be improved using the test set. Okay. Once tested, the model can now be deployed to be used for predictions on new data set. There are different approaches to supervised learning. One is what we call classification. So one is to predict a value or example, predicting, and one is regression, and the other one is classification. So for regression, this one is, we're going to predict an exact value, predicting, for example, predicting the temperature, or another example is predicting the wind speed or the amount of rain in millimeter. Now, these predictions can be, yes, like I mentioned, a numeric value from a continuous interval of real numbers. We call this method regression. Now, it can be applied to time series data. These data are a collection of quantities. When we say time series, they are quantities that are assembled over regular intervals in time and ordered chronologically. And basically, most often they are numeric data ordered in time. Now, the other approach to supervised learning involves predicting a group or an outcome from a discrete classes. For example, if you want to predict whether it will rain or not, so that's an example. That's a binary classification. Or predicting the intensity of the storm according to conventional categories. We have signal number 1, signal number 2, or signal number 3, or signal number 4. So basically, that's classification. Now there's this another workhorse of machine learning is called deep learning. Deep learning, also called representation learning or hierarchical representation learning, is an area of machine learning that heavily relies on artificial neural networks. So artificial neural network, just think of it as just one of those algorithms present in machine learning. But this basically is, I think, based on experience, no, this is more powerful and more accurate, and given given that if you feed it with a lot of data, I think most of the time this has proven to be more accurate than the other machine learning algorithms. Now, it relies heavily on the artificial neural networks and inspired by the structure and function of the brain. There are three layers of the neurons in the neural network. You have the input layer where data is actually encoded, and then the hidden layers where data are being processed, and then you have the output layer where the result will be outputted, and based on the result, you will have your predictions. Okay, so basically, your data input are being weighted and aggregated, and the result of this aggregation is transformed by an activation function to make sure that we also accommodate the nonlinear scenarios. There's an iterative mechanism on how weights are being adjusted based on the inherent pattern in the data. So there's an algorithm that actually configure what weights will you apply for each of the data sets so that you will be able to come up with a better prediction. And the graph above, the graph there, as you can see, machine learning versus deep learning, that graph above highlights the scalability of deep learning, indicating that the results get better with more data as compared to machine learning. So if you're going to use deep learning, make sure that you have a lot of data that you can use. However, deep learning would require more computing power as well. Speaking of computing power, we in DOST-ASTI have enough computing power to do deep learning research through the core infrastructure or the computing and archiving research environment installed in ASTI. So as a matter of fact, we have applied deep learning in this particular research, and this research actually uses convolutional neural networks, also a deep learning architecture. And basically, CNN or convolutional neural network works well with images. Okay, and what we did here is basically we have converted the time series data that we collected using the weather stations that we have deployed all over the country, and converted those time series into images, okay, using what we call a recurrence plot. But there are many other ways of converting those time series images to those time series into images. We just chose in this research to use recurrence plot. And when we have collected enough of those images, these images representing different weather parameters, basically we stack them together and we fed them into a deep learning neural network. And the output would either be one of the color-coded combination, color-coded output of the rainfall advisory, red warning, orange warning, yellow warning. So this, and also white, which means there's no rain. Okay, so this is a fourfold classification task that we did here, and the experimental results in this classification task yields a 96.27% accuracy. So this one is, we did deep learning for the precipitation forecasting, or forecasting whether it will have a red warning, orange warning, yellow warning, or will have no rain in the coming 6 or 24 hours. Okay, and actually that research is part of the ULAT project, or Understanding Lightning and Thunderstorm, which I will now be discussing. Okay, the project aims to observe the country's weather behaviors through studying torrential rainfall and thunderstorm occurrences as parameters, eventually to enable short-term forecasts. So that's one of our main goals. And it is actually a collaboration between ASTI, the UP Institute of Environmental Science and Meteorology, or UPIESM. Of course, we have ASA on board, the weather authority of the country, and we are being helped, assisted and supported by the professors from the Hokkaido University with our research. And this project is also supported by the Japan International Cooperation Agency, or JICA. And there have been research studies that analyze lightning activity and the relationship between lightning and the rate of maximum sustained winds or intensity of the typhoon. Okay, so this is one of the motivations of the project. This is one of the impetus why that project has been actually conceptualized, because there have been research from before, like for example this one from Price et al., that there is really a strong relationship. If there's a lot of activity, lightning activity, and a typhoon will actually follow, or a maximum sustained winds will actually follow the presence of lightning activities. So what are the goals of the ULAT project? So it has 4 main goals. One is to establish the dense and nationwide lightning systems. And then 2 is to establish a 3D satellite monitoring system, and then develop algorithms for forecasting. Most of these algorithms will utilize machine learning, and establish data sharing for related agencies in disaster risk reduction. So this is a very important goal. We should be able to involve stakeholders and other government agencies and share data with them so that they be able to come up with better advisories. For the dense lightning system, we have stations being deployed in NCR, Cavite, and Rizal. Basically, these are we use plate sensor to detect lightning in this system, and it also has other weather parameters, weather sensors involved for collecting other weather data, rain gauge, and collecting rainfall data. Basically, we already have deployed 34 out of 50 deployed stations. One of the reasons why it's taken so long because of the pandemic. I think if the pandemic did not happen, I think we have somehow reached, we have already probably deployed 50 stations already within Metro Manila. So this is a dense lightning system. This is more the type of crowded or more close to each other weather sensors. But we also have the nationwide lightning system. So stations being deployed, 10 selected Pag-asa regional offices nationwide. And then it uses VLF antenna to detect lightning. So VLF sensors frequency range, it has a frequency range between 1 and 40 kilohertz to measure the electric field radiated from lightning discharges, and are distributed 100 kilometers apart. So these are long distances. Okay, this is not the dense lightning system that I've shown you earlier. Additionally, slow antenna and electric field mill are also installed to detect electric field change by lightning discharge. It also has automated weather sensor and rain gauge for collecting rainfall data. And the status of this system, we have already deployed 6 or installed 6 out of the planned 10 stations. Okay, now I call this the confluence of data. So you can see here, as I mentioned before, we have installed weather sensors all over the country. Aside from that, we also collect satellite images based on the ground receiving from the ground receiving station of the, for example, the Diwata satellites, and then couple that with other data sets, and we house them in a data server in ASTI, in the computing and archiving research environment. And currently, the ULAT team is now developing a data processing system for those data sets so that we can provide the public with visualizations and end user API. Okay, these are sample screenshots for the rainfall and temperature data on the ULAT project data viewer. This is part of the ULAT application that we're currently developing. We also maintain a website containing all the sensor data that we collect for anyone interested in working on these data sets. This is the Field Sensors website. I'm going to show the link later after my presentation. And yeah, as a research development institute, we do a lot of research and development. This one is actually a research collaboration between ASTI, IESM, and Japanese scientists from the Hokkaido universities. And this one is a 3D cloud reconstruction. So there's a research about the development of effective observation methods through comparing 3D structures of thunderclouds using satellite images. So the images with lightning and precipitation data coupled with the DEWATA satellite images, so nag-create sila ng 3D reconstruction of the clouds. Kasi yung cloud, kasi it's a very important predictor ng typhoon, no? Yung cloud, lalong-lalo na kapag mataas yung height ng cloud. So basically, yon. But the thing is, with just the images, okay, 2D lang siya, mahirap malaman talaga kung gaano kataas yung height ng cloud. So what they did some research and they come up with a 3D reconstruction technique, a very, very accurate compared to other researches. So very, very accurate yung 3D reconstruction technique nila, and this is proved very useful. And also, lightning activities were reported coming from the Pasig area. So we also have some who have validated our research based on testimonials and news reports. No, so, based from the data that we collected and the result of our research, they are somehow validated by news reports and sightings, no, including the increase of lightning activities, for example, for a particular event, for example, like in Taal volcano eruption. During that time in January, madaming mga instances ng lightning activity in a certain area, and it was validated naman by the data that we have collected. And so thunderstorm tracking is now possible using the dense network that we have deployed and our artificial intelligence that we're currently studying, and of course the skills from the researchers working on this project. So ipapakilala ko lang sa inyo yung team. So ito yung isa sa part ng team ito. Actually, we went to Tanay in one of the Pag-asa stations in Tanay for our Radioson campaign. Yung Radioson kasi basically yung nasa right. So ikinakabit siya dun sa weather balloon na nasa left. Tapos yan yung part ng mga ULAT team. And ito yung mga links naman for if you're interested to actually acquire the data or read more about the activities or the initiatives that we have been doing for the project. And I think that's it. Thank you for listening. I just hope that I have encouraged and inspired everyone to be interested enough to explore more on this topic. Sorry, medyo short lang, pero the objective here is you get to be inspired and somehow informed, and then interested enough to explore more on the topic that I've just discussed. I think that is all. Thank you very much.
Hey, thank you, Sir Elmer, for that informative discussion. We can clearly see the importance of harnessing these tools of technology such as machine learning for a more accurate weather forecasting system, especially here in the Philippines where the weather can be quite unpredictable. So again, if anyone wants to know more about the ULAT project or our other projects at DOST-ASTI, you can head to our website or follow us on our social media channels. So now, for the last portion of our webinar, we will be starting the Q&A session. So Sir Elmer will be joined by the other members of the ULAT team. So here is Sir Glenn Lopez, Sir Jericho Orejudos, and Sir Jeff Aborot. So sirs, kindly turn on your cameras and be ready to answer questions. So for those who are streaming this event via Facebook Live, you may type your questions in the comment box. Okay, so is everyone ready? Can we flash the first question, please? Okay, so the first question says, I am a data science student. Is it possible for me to get a hold of the weather data assets that I can use for my research project? what procedures do I need to follow to use the data collected by the weather stations for my research? I guess Sir Elmer can answer po. Thank you.
Hi, thank you, Thiris. Yeah. I think they would need to write a parang or email the ASTI director, Dr. Franz, and then it's out. The data naman are actually free for especially for research purposes, but they should comply with the ULA or the end users licensing agreement. So yung procedure lang siguro yun, letter lang to the director. Glenn, do you have something to add regarding this?
Yes, thank you, Elmer. So good afternoon, everyone. Actually, as part of the project, as mentioned earlier by Sir Elmer, part of the project is to share data and all information collected coming from the ULAT project. So all the data that we have can be shared, especially for those who will use this data for their research or academic purposes, and also for disaster-related mitigation initiatives of especially from the local government's units. So we have partners who are already using the data, so we seamlessly share the data. And also, as mentioned earlier, most of the weather data are being shared online publicly through the Field Sensors website. And we are also developing other tools and platforms in order for us to share the data in much more target audiences, or mas madaming pwede naming ma-reach na partners for the use of data. Thank you.
Okay po. Thank you, Sir Glenn and Sir Elmer. So just to add, you can send an email address to the director, to the DOST-ASTI director, Director Franz De Leon, to info@asti.dost.gov.ph. So can we have the second question, please? Just for a while. Question number 2, do you also use social media data like tweets to validate or correlate the result of your research in the ULAT project?
Okay, let me answer that. May research akong na-encounter before that they use mga tweet data to actually parang validate yung ano. Pero in the ULAT project, kasi we haven't done that yet, but siguro later we can actually make use of the social media data or tweets, no? Kasi that's another, ano pa kasi, we have actually a lot of data sets, no, that we're working on. And siguro kapag we have enough more time, we can actually consider using Twitter data, no? We would probably implement a web scraping tool to actually scrape yung tweets, and then tingnan namin dun sa mga predictions namin if it really correlates with our prediction doon sa mga. So pero medyo that's another part pa kasi kumbaga medyo this is a research area on its own, no? Medyo this is malaking effort din ito kung gagamitin natin yung yung Twitter data. Pero as of now hindi pa siya namin ginagawa. Pero maybe in the future.
Okay, thank you, Sir Elmer. Our question number 3 is from one of our guests. Hello, not sure if I missed it earlier. How was the results of the forecast validated?
Yeah, with that, kasi since we're collecting, we've been collecting data sets, I think as early as 2019, no? So medyo marami kasi yun. Tapos minute yung resolution. So imagine, big data talaga siya. So like yung pinapakita ko kanina na meron tayong training set, tapos meron tayong test set. No? So basically, time series siya. So gagamitin natin we're going to use part of that data set that we have to come up with a model, and then gagamit din tayo, let's say, ng another set for actually tuning the model para maging. And then yung later part siguro yun yung ginagamit, no? Yung later part yun yung ginagamit namin to validate kung kung accurate yung aming results. So that's how we actually validate, one way to validate our data sets. Kasi yung hindi naman lahat ng data na yun gagamitin namin for training. Some of them we will set aside for actually the validation.
Okay, thank you, Sir Elmer. Can we have question number 4, please? Okay, question number 4. In machine learning, what are the factors that affect the accuracy of your predictions?
Sige, I'll also answer that question. So, yung mga factors that affect the accuracy of predictions sa machine learning in general, I would say siguro number 1 dito with the quality of your data. So napaka-crucial nung data collection. So kasi pagka garbage in, garbage out, basically, kapag yung data kasi yun yung ating parang fuel, no? Yung ating ini-input doon sa ating machine learning algorithms. So kapag yung data mo hindi malinis at hindi accurate, syempre hindi rin tayo magkakaroon ng accurate na result. So dapat they are well structured, tapos clean, and then as much as possible we minimize the missing data, and then i-minimize din natin yung mga confounding and also mga redundant data sets. Sometimes kasi nakaka-apekto din yun sa performance ng model, ng accuracy ng model. Aside from the data, yung algorithm itself also can be also kailangan kasi hindi lang actually yung data yung dito, pati yung distribution ng data or yung property ng stochastic processes na nag-generate dun sa data. Kasi kaya importante yun, kailangan kasi dapat ginagamit natin yung assumptions doon sa mga model natin. May mga assumptions kasi tayo pag gumagawa tayo ng mga predictive model, like for example, dapat constant mean para mas madali and constant variance, yung mga ganon, yung mga statistical assumptions. So yung kung paano na-generate yung data na yun, yung stochastic process behind that, iba-iba yun eh. Merong kasing parang somehow deterministic, merong highly stochastic, merong chaotic, no? Pag chaotic yung data mo, ibig sabihin konting pagbabago lang dun sa ang laki ng usually mga weather data ganon. Property niya very much chaotic yung nagiging outcome. Kapag small changes lang in the initial conditions, it could mean a very large or very drastic change doon sa outcome. So yun din yung stochastic property ng stochastic process na nag-generate dun sa data. And so also yung sa algorithm, meron tayong tinatawag kasi na underfitting or overfitting. So kailangan din natin ma-make sure na just the right amount or just the right parameter values yung ginagamit natin doon sa model. I guess yun yung mga naisip kong factors para na nakaka-apekto sa accuracy ng mga predictions in machine learning in general.
Okay, thank you, Sir Elmer. So our next question is from our audience. Hi, why is there a need to transform po the temporal data into image? Is there a possibility to lose the temporal autocorrelation of the data sets with the transformation? Thank you po. So anyone po can answer?
I will answer na lang yung question na yun. So with regards to that, that's a very good question, no? Doon sa siguro nakita niyo yung research na pinakita ko kanina na yung time series kinonvert namin sa Okay. Nabanggit ko kasi the reason why we did that is because we're piggybacking on the success of CNN. Very successful kasi yung convolutional neural network sa deep learning, taas yung accuracy niya. So we just thought of that. Pero yung concern naman about the losing the temporal autocorrelation, That's the reason why we choose recurrence plot. Yung recurrence plot method kasi doon na-preserve niya yung temporal autocorrelation. Yun naman yung reason. Ibig sabihin yung recurrence relation nung time series mo na-preserve niya kahit na naka two-dimensional na siya. It just depends now on some parameters lang. May mga parameters kasi sineset para actually ma-capture yung temporal autocorrelation ng time series. But this is a very good question, by the way. Thank you.
Okay, thank you again, Sir Elmer. Our question number 6 is another question from the audience. Just a curious question. Usually, when time series data are involved, RNN is used. What is the reason for choosing CNN over RNN?
Yeah, tama naman. Yung RNN kasi is recurrent neural network and ginagamit usually ang RNN sa sequence data and time series is a sequence data. Ayan, just like yung sinabi ko kanina, yung CNN is very effective kapag sa data set. Pwede naman, actually we also use RNN, specifically LSTM, doon sa time series data. We did not convert, yung pinakita ko kanina is just one of our research. Pero since we're dealing with a lot of time series data, it's inevitable for us not to use RNN or LSTM, no? Specifically LSTM yung ginamit namin. Kaya lang dito, this is just another method, no? So, kasi basically ang deep learning or science itself, maraming way. Actually, you can explore a lot of ways. And ano lang to, parang let's say ingenuity siguro, no, that you can actually do that. It's not necessary kasi yung piniliwanag ko nga kanina na very successful yung images. Okay, ay yung CNN doon sa mga images. So why not convert yung time series data by preserving its temporal autocorrelation and then use CNN. Okay, but yeah, it did not preclude us to use RNN in our research. It's just that kumbaga parang ginamit din namin yung CNN tapos kinonvert naman namin yung time series into images. So both actually ginamit namin. And it's true na most time series data or sequence data ginagamit RNN. Pero gumagamit din ng CNN po. Kapag kahit na time series data or kahit sequence data, pwede rin gamitin si CNN.
Okay, thank you, Sir Elmer. The next question is for Sir Jeff. From our audience, Sir Eric Aldwin Suarez of Gapan, Nueva Ecija, magkakaroon din po ba ng Android app para sa prediction forecast mula sa ULAT project? Salamat po.
Hello, good afternoon. Thank you for the question. As of now, wala pa sa pipeline ng ULAT project yung pag-develop ng Android app. But currently, we are developing REST APIs that can be used for developing either web application or Android application front end. So siguro pag nasa pipeline na yon, the project will also announce para sa kaalaman ng mga gustong mag-build on top of the dataset. So dinesign namin siya na exposed via REST API yung dataset so that mas free tayo na mag-develop ng applications on top of the data na kung saan may contextualize natin doon sa problem na gusto nating i-solve, na kung saan makakatulong yung weather data or lighting data. So siguro if with the succeeding phases of the project, no, magkaroon ng decision to expose the APIs, then the management or ASTI will let the public know about it.
Okay po. Thank you, Sir Jeff. The next question po is for Sir Glenn or Sir Elmer. From our Facebook Live audience, good afternoon po. Sino po usually ang pwedeng maka-access sa HPC resources po sa core? Thank you.
Okay, let me answer the question. So, basically, any government or research institutions are free to request for access as long as the intended use for the use of the HPC is for primarily for research and development use or purposes only. So anyone from the research community, as long as na gagamitin siya sa R&D and of course hindi siya gagamitin for commercial or parang pagkakakitaan na paggamit ng HPC, ay pwedeng gumamit ng HPC resources sa core. So kung merong interested po na gustong gumamit ng HPC resource, you can email po yung greetops@asti.dost.gov.ph. So ilagay na lang din po namin sa chat box po yung email link for further inquiry po about the HPC resource. Thank you po.
Okay, thank you, Sir Glenn. So I think we are down to our last question. Question number 9 is for, again, Sir Elmer. Good afternoon po. I am a ComSci student and here is my question. In terms of machine learning and AI possibilities, what are other issues that your team can tackle? And do you have any public or open access tools we can use for testing data visualization, etc.?
For siguro ComSci students in general, no, public open access tools. So yung na-mention ko kanina, we are developing parang a web applications, no. Tapos basically nabanggit ni Jeff kanina na i-open yung API noon. I think that's one, no, na pwede nilang since through API of yung system na ginagamit namin, no, through web APIs, yung mga programmers like yung mga ComSci students can actually siguro yun nga get the data or some of the visualizations, or they can use them, no, via the web APIs.
Okay, so meron pa po bang gustong mag-add from the team? Okay, I think we have one last question po from the audience. Question number 10. Are there plans to integrate this with Pag-asa's forecasting?
Let me answer this question. Yes, for this ULAT project, actually kasama namin si Pag-asa on this project, and this project is intended to be transferred or being turned over to Pag-asa after the project implementation. So they are the actually the sole end user or targeted agency for the stations, yung madi-develop din namin na tools, as well as yung mga magiging result ng researches na ginagawa namin under the project. So basically after the project, turn over nga namin yung mga stations, then sila na yung magme-maintain, tapos yung tool na gagamitin is may integrate na dun sa mga existing tools nila as a complement for parang additional tools nila for their weather forecasting and their operations. And also, currently we are having coordination with Pag-asa team to integrate the data that we collect as early as now to their Pag-asa PUMI system. So the PUMI system is an integrated system for Pag-asa na doon nila nilalagay lahat ng data na nakukollect nila from all different sources. So ito yung wino-work out namin ngayon, and ongoing pa yung development on this matter. Thank you.
Okay, thank you, Sir Glenn. I think that ends our Q&A session. Okay, so thank you to our Q&A panelists. We would like to thank our guests as well for your questions and your active participation throughout this event. For additional questions, feel free to send us an email at media@asti.dost.gov.ph. and our DOST-ASTI team will make sure to answer the best way they can. So one last request before we finally end. I hope you are all ready for the photo op. May we please invite everyone to turn on their cameras. Our team will be promoting the attendees to panelists. So kindly hold your smiles, and while we are waiting, for everyone's information, there are still NSTW events over the weekend. Okay, so let's just wait for the attendees to be promoted. For those asking for the certificate, unfortunately, we are not issuing certificates as of the moment, but we'll let you know in our future webinars. Okay, Aldrin.
All right. Again, we're inviting everyone to please turn on their cameras.
So you can see on the screen the NSTW webinars over the weekend, Saturday and Sunday. So maybe we can start the photo op, Aldrin. Thank you.
All right. I think everyone is turning on their cameras. So, yeah, please hold their smiles. Please take this photo opportunity. In count of 3, 1, 2, and 3. All right, there we have it. Thank you.
Okay. Thank you, Aldrin. And that concludes DOST-ASTI's lineup of webinars for this year, National Science and Technology Week. But we hope to see you again in our future events. So on behalf of DOST-Advanced Science and Technology Institute, thank you very much for being here with us. This has been Therese Kilnat, your host. Stay safe, stay curious, and have a great day ahead. Thank you po.